Alright, so now we're going to have a look at another question. This comes from the 2020 HSC Advanced Maths paper. Now this is a sort of a geometry question. It's about graphing functions or relations. This one has a really nice method. We're told a circle has a particular form and it's reflected in the x-axis. We need to sketch the reflected circle, show the coordinates of the center and the radius. Easiest way to do this is just draw the circle we've been given and then reflect it along the x-axis. So we'll draw two circles here. First the one we've been given, then the one that's reflected. You don't need to draw the first one, but just drawing the first one will pretty much show you what the reflected one is going to look like. So it's question 24. We have x squared minus 6x plus y squared plus 4y minus 3 is equal to 0. So whenever you have this form where you have an x squared, an x, a y squared, a y, and a number, this usually is a circle. It's not always a circle. You can have things that look like this that have slight variations of the coefficients or the terms, and they might be ellipticals or other conic sections of some variety. There's a whole heap of those later on that you may encounter. But what we need to do is we need to complete the square on the x's and on the y's, because we need this in a very particular form. So to complete the square, divide minus 6 by 2, that's minus 3, square that, that's plus 9. We're going to add 9 to this section. Divide plus 4 by 2, that's plus 2, square that, that's plus 4. We're going to add 4 here. Given that we've added 9 and 4, we have to add 13 to the other side. So we're going to add 13 over this side. We're then going to move the 3 to the other side by adding 3 to both sides. This will give us x squared minus 6x plus 9 plus y squared plus 4y plus 4 is equal to 16. This is a perfect square, and it is actually the perfect square x minus 3 all squared. It has to be a perfect square because a perfect square from these formulas is always x minus 1/2 of whatever this number is, and the number at the end is always half of whatever this number is squared. That's why we knew to add 9 and 4 to this. And then we have plus, this is also a perfect square, y plus 2 all squared. This is equal to 16, which is actually 4 squared. Now a circle has the relational form x minus alpha squared plus y minus beta squared is equal to r squared, where alpha, beta is its center, and r is its radius. So here in our example, we can see this is the formula we're going to be using. This should not be here. This is known information. You will have encountered this typically in year 11, and then again it's introduced in year 12. So in the circle we have, in this one, the center is going to be at 3 minus 2, and the radius is going to be equal to 4. So if we draw a graph like this, the center of the first circle will be at 3 minus 2, 1, 2, 3, 1, 2. That's down here, radius 4. It'll look something like this. If we reflect it in the x-axis, the center is going to move up here to 3 plus 2. And it's going to look like this. So, because I'm on the iPad, I can just get rid of this first circle and just draw the reflected version. If you're doing this in an exam, you can draw the first circle, then draw a second graph with the reflected circle, then specify that the second graph is the reflected circle. So this is the center. Its radius is 4, which means it goes out to here, goes over to here, goes pretty much all the way up here, pretty much all the way out here. This is 4, 5, 6, 7. And then we're just trying to draw the smoothest circle we can. Your circle doesn't need to be perfect, it just needs to be fairly reasonable. We need to show, label this is the y-axis, this is the x-axis. We need to show that this is the point 3, 2, and we need to show that the radius here is 4. So we used the formula we were given to find what that thing looked like. We worked out it was a circle. We were able to identify it was the form that circles come in. We were then able to solve it to find out specifically which circle it was. We drew that circle, then we reflected that circle along the x-axis. That gave us the new circle. We then drew that new circle. Now, because I'm working on an iPad, I can just get rid of the first circle and then draw the second one. If you are in a pen and paper exam, it's not a bad idea to draw both of them. Draw the original function, then reflect along the x-axis, then draw the new function, the reflected one, and then state that that is the reflected function. So say the reflected circle has this center, has this radius, this is the reflected one, this is the original one. Something along those lines. You don't have to draw the original one. The question did not ask for this. Often it's just not a bad idea to draw the original ones. So let's talk about the marking. The marking here is pretty straightforward. You have to complete the square for the equation or do something similar to try and get this into a circle form. So that'll be this bit up here. It'll be some working to try and take the equation you've given and turn it into something that helps you identify this is a circle. Completing the square is the easiest way to go here. The second mark will be finding the center and radius of the original circle or of the reflected circle. Ideally, you'll have both of these, but they'll want you to have resolved the equation, work out what the circle is, and then find information about one of the two circles, either the original or the reflected one. So that will get us down to about here. And then the third mark is provide correct solution. So you will need a graph of the circle, a reasonable graph of the circle. It'll have to have, ideally it will have the radius distance labeled in the diagram, and it will have the center of the reflected circle. So this is approximately how this question should work. A lot of students will just get stuck at the beginning. There will be many students who can't do this question at all because they have forgotten about the relational forms of circles. This is mostly taught in year 11. It is mentioned again in year 12, and students should be revising content occasionally as they go through the course. This ideally should be something that they have fresh in their mind, but it's something that's often forgotten. So when you do circles, it's ideal to make sure that you memorize specifically this formula, right? This is often the formula that you see if these questions are going to appear in the HSC, certainly for the advanced maths papers.